This is problem number 1 from assessment number 5. In this problem, they say the half-life of a certain radioactive substance is 36 hours. There are 10 grams present initially. Express the amount of substance remaining as a function of time t. When will there be 1 gram remaining? So they're wanting us to write an exponential decay or half-life formula for this problem. The half-life formula, if you remember, is y equals, you would call this a b to the t over k, where a stands for the initial amount, b is the, in our case, this will be the half-life percentage, and then t is the time it takes, and k is the half-life time. Now, one thing that's important about k, although it's the half-life time, they tell us that k is 36 hours. You can represent k as the number of hours, or you can represent it as the number of days, and sometimes they vary in which one they want in my math lab. So just keep that in mind, that if you put in a formula with 36 hours and it says it's wrong, it may want it in days. So let's go ahead and do part A, and let's write down what we've got. So our initial amount is 10 grams. So A equals 10 grams. We know B is going to be, well, it says half-life, so B is going to be 0.5. And then we know T is what we're going to be looking for. That's part B. When will there be 1 gram remaining? We can say that Y is going to be 1 gram. Now, I'm not going to use that till part B, but we can write that down. And then K is going to either be 36 hours or 1.5 days. Either one. Yeah, and it depends on what they want. Do they want it in days or do they want it in hours? And they'll tell you in blue what they want. For me, I'm going to use the 36 hours just because I know they're asking for the solution to this problem in part B to be in hours, so we might as well just start with hours. So our initial equation is going to be y equals 10, plug in 0.5 for B, right? We're using this equation, to the t over 36. So this is part A. Now, if they want it in days, you would say t over 1.5. For part B now, they say, let's find when there will be 1 gram remaining. So we're going to say 1 equals 10.5 to the t over 36. And now we have to solve this exponential equation. First thing I'm going to do is divide each side by 10. And I get 1/10 equals 0.5 to the t over 36. And now I'm going to take the natural log of each side, so I'm going to go over here and take the natural log of each side because I need this exponent to come to the front. So I'm going to end up with natural log of, and I'm going to write this as 0.1, right? 1 divided by 10 is 0.1, equals natural log of 0.5 to the t over 36. This can come to the front, so I get natural log of 0.1 equals t over 36 times natural log of 0.5. Now I need to multiply by 36 on each side and then divide by 0.5. So I'm going to say times 36 and times 36. So I get 36 natural log 1 equals, and then this would be t times natural log of 0.5 because the 36 is canceled. Last step is to divide by natural log of 0.5. And we're going to end up with 36 natural log 1 over natural log of 0.5 equals t, which equals, let's go ahead and plug that in the calculator. And when we do, we end up with oh, you know what I forgot? I messed up. This one right here. Ooh, this is 0.1. This should be 0.1 here, so I keep typing in 1. This should be 0.1. My marker kind of got all spludged, so that's natural log 0.1. So that was a little mistake there. Let me plug that in. I kept getting 0 and I was wondering why. So 36 natural log 0.1 divided by natural log of 0.5. And we end up with 120 when we round it up. It's 119.5, but we rounded it up to 120, and that'd be hours. So this is 0.1, just keep that in mind. I kind of screwed that up as I went down because I missed it right here when I wrote it. I put 0.1 there, but it didn't show up very well. Hope that makes sense.